Today's notes on 20.1 are on data gathering techniques. And so the way that we go about conducting surveys or collecting data can sometimes affect the outcome of that data. And so we want to think about how and when and where and from whom we're collecting that data. In the notes, we start out with examples of the difference between a census and sampling. And so it has to do whether you're surveying all of the individuals in a population or whether you're only surveying some of the individuals in a population. When it comes to collecting data, there are 6 different types of sampling methods that you can participate in. And so it might help to go through on these ones right here and number them 1 through 6. And so in the first part of the notes today, we're going to go through and we're going to discuss each of the definitions for these 6 different sampling methods. So in a self-selected sample, that's when somebody volunteers to be a part of the sample. So the person that's participating is volunteering to participate. The second type of sampling method is a convenience sample. And in a convenience sample, it says that that's obtained when individuals are selected based on how accessible they are. The data is easy to obtain. And so I think accessible, easy, we'll look at examples of each of these later, but in a convenience sample, you might be asking people the question just because you happen to be where the people are. In the third sampling method, a systematic sample is obtained when members of the sample are chosen according to a rule, such as every nth individual in the population. And so an example for that might be if you were going to ask every 4th person that walked by you or every 15th person that walked by you. That's what it means by nth right there. So it's asking people in some kind of a pattern based on a number rule. In a simple random sample, that's obtained when sample members from a larger population are selected entirely by chance and each individual in the sample has an equal chance of being selected. And so that would be like using some kind of a list to randomly generate people to participate in the sample that you're looking to obtain. For most students, questions 5 and sampling methods 5 and 6 are the ones that are the hardest to keep straight in your brain. So one of them is called stratified and one of them is called cluster. And I think the reason why they're so tricky to separate is because they're so similar to one another. In a stratified sampling, it says the population is divided into groups. And then in a cluster sample, it also says the population is divided into groups. And so in both of these, you're dividing the population into groups. But then it's the last part, so groups and groups, that's the same. But it's the last part that's different. In a stratified sample, it says individuals from each group are randomly sampled. And then in a cluster sample, it says some of the individuals in the groups, in selected groups from the groups, are randomly sampled. So in a stratified sample, when they're broke up into groups, and then you survey some people from each one of the groups, but from all of them. In a cluster sample, you still break it into groups, but then you only survey some of the people. And so those are the 6 methods of sampling that we can obtain in when we're trying to conduct a study or some kind of survey. So in the notes today, we're going to start by looking at an example where we need to classify each type of sampling method. And so by reading each one, we'll refer back to the definitions to help us answer these questions. In the first example, it says a small private university wants to know whether students would prefer to purchase a yearly parking pass or a quarterly parking pass. And they want us to classify each sampling method. Not all of them will be used because there's only 1, 2, 3, 4, 5 examples in this question, and we have 6 different types of sampling methods. So in question A, it says survey every 30th student who's enrolled, and so this number right here means you're following a number rule for answering the question, and so this one would be a systematic sample because you're following a number rule. On B, it says survey 50 randomly selected first-year students, 50 randomly selected second-year students, 50 randomly selected third-year students, and 50 randomly selected fourth-year students. So you're breaking the population up into groups, and then you're randomly sampling students from each one of those groups. And so looking back at the definitions, we'll see that that one is an example of stratified sampling. It would be cluster if they broke them into groups, but then didn't survey people from each one of the groups. But on this one, they broke them into groups, and then they surveyed randomly selected people from each of the 4 groups. And so that's what makes that one stratified instead of a cluster sample. In question C, you're dividing the students up into classes, and then you're surveying all of the students in 4 of the calculus classes. So not all of the calculus classes, not all of the classes on campus, just in 4 of the calculus classes. And so that one's going to be a cluster sample because you're not surveying people from each one of the groups that the school would be broken into. On question D, if you survey a random selection of those who happen to be in the on-campus coffee shop at 8 a.m., that would be an example of a convenience sample because it's convenient that they just happen to be there in the coffee shop. And then E, survey those who ask the student union for a questionnaire. That's going to be self-selected because the people who participate in the survey are choosing to participate in the survey. In the next example, it says to decide whether the sampling method could result in bias and to complete the explanation for your reasoning. Before prom, all of the seniors attend an end-of-the-year informative assembly. Afterward, the vice principal wants to learn the opinions of the seniors regarding the assembly. He decides to ask 30 seniors as they leave the gym to complete a questionnaire. So bias means that the results of the survey could be affected by the type of people that you're asking or where you're asking the question or how you're asking the question. And so in this example, he's asking the seniors who were at the assembly about the assembly. He's asking 30 seniors as they leave the gym, so you could argue that it's random. And so in this example, we would say that the sampling method is not likely to be biased, which is a good thing, since the sample is random. And all of the seniors, theoretically all of the seniors would go to the assembly, are available to be chosen. So bias is going to come into play when you're asking the question in a place or you're asking a certain population of people or the way you're asking them the question might result in them answering it a little bit differently. All right, so moving on with some other examples. Administrators at a school want to know if students think that more vegetarian items should be added to the lunch menu. And so there's a couple different questions that follow up with this one. The first one is there's different ways they can ask the questions. So if they survey every 20th student who enters the cafeteria during the lunch period, they're following a number rule. It's a systematic sampling method. And then the reason why it's systematic is because they're following the rule of every nth student. So if they used that as their sampling method, it would be systematic. Using a systematic sample in this example is not likely to result in a biased sample because in the way that they're asking the question, a wide range of students will be surveyed because they're surveying people that are in the cafeteria according to a number rule. On B, if they instead used a randomly generated list of 50 students from a master list of students, I think the word random and all are the words in this one that help you answer the question. It's a simple random sample because each student has an equally likely chance of being chosen. And so because of that, it would also not be likely to result in a biased method because the students are being chosen randomly. And so remember, when it comes to bias, it's good if it's not biased because being biased means that your results might be affected in some way. In the next example, the administrators survey the first 75 students who get in line to buy lunch. Remember, the question has to do about buying lunch. If they ask the first 75 students who get in line to buy lunch, that's going to be a convenience sample because the students are easily accessible. And so you want to think about what's happening in this example. They're asking a question about what should be on the lunch menu. And so if they're asking people who are in line to buy lunch, you might want to consider that this method could result in a biased sample because it doesn't include students who bring their own lunch. What if there are students who bring their own lunch? Because the school doesn't offer enough vegetarian options, their opinions would not be included in the survey. So you want to think about differences there. Categorical data is when the data is broken up into, usually we say words, but categories. So the answers are groups or categories. Numerical data is data where the answers to the questions or the numbers are numbers, so they're values. And so if you were asking the students who were interested in adding more vegetarian options or what kind of options they would like, that would be an example of categorical data because their answers would either be yes or no, or their answers would be what types of foods they would want to see on the menu. In the second part of the question, it says the amount that students would be willing to pay for vegetarian lunch items. So that would be numerical because your answers to that question would be number values. All right, so in this final example, it says Julian is interested in purchasing a used sports car. He selects the make and model of the car at a website. It says in the directions to the question that the website delivers a list of 130 cars that meet his criteria, in that he randomly selects 10 of them and records what type of engine and what type of transmission they have. So let's see. So manual, 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 automatic, manual, automatic, manual, automatic. So it looks like there's 1, 2, 3, 4, 5, 6, 7 manual, and then 3 automatic. And then on the other side of the list, so V8, 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 so V6, 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 V6. So in this example here, I went through and I color-coded them just to help us with counting them later on. And now we're going to answer some questions about what percentage or about what number of cars in the list have each of those values. If Julian only wants to drive cars with manual transmissions, predict the number of cars on the website's list. So we're going to use the 10 cars that he picked to help us answer these questions. The first thing it wants us to do is it wants us to figure out what percentage of cars have manual transmission. So we're going to count up the manuals. 1, 2, 3, 4, 5, 6, 7. So if 7 out of the 10 cars in the sample list have a manual transmission, and we're being asked to figure out what that is as a percentage, remember you divide 7 divided by 10, that gives you 0.7, and then to turn it into a percent, you would move the decimal point 2 places to the right. And so 70% of cars would have a manual transmission if this sample was representative of the population. The second part of the question says they want us to figure out the predicted number of cars in the list of 130 total cars that would have a manual transmission. And so there's a couple different ways that you can do this. You can either solve it like a proportion, or you can use multiplication to solve it. If 70% or 0.7 of the cars in the list above have a manual transmission, to figure out percent of a number, we can multiply the 0.7 or the 70% times the 130. And so when you do that math out in your calculator, you would get an estimation that out of the 130 cars in the whole list, there would be about 91 cars that would have a manual transmission. So I use the decimal value of the percent, and I multiply that times the total percent of a number, so we're going to multiply. And in the final example, it says that Julian knows that the V6 engine takes regular gasoline, but the V8 engine requires premium gasoline. And so it says that he wants to do V8. And so they want us to predict how many cars in the list have the 6.2 liter V8 engine. So we're going to look up on the list. So there's 1, 2, 3, 4, 5, 6. So on the list, there's 6 cars that meet that criteria. So to figure out that percentage, we'll do 6 divided by 10. Again, that would give us 0.6. And then to figure it out as a percent, we're going to move the decimal point 2 places to the right. So 60% would be the percentage of cars that meet that criteria. And then down here in the final example, they want us to use that percentage. So if we predict that 60% of the cars have the 6.2 liter V8 engine, we're going to multiply that times the total. And when we perform that multiplication, that's going to give us 78 cars as an answer. So again, if the sample is representative of the population, since 6 out of 10 cars had this characteristic, we would expect that out of 130 cars, there would be about 78 of them that also have that characteristic.